What is similar about your sequence? Okay, pod 6. What similarities do you notice? What?
They all increase at a constant.
They all increase at a constant rate. Did anybody else make that observation? In pod 4, what observation did you make?
We just noticed like how much they go up each time. Like they all go up at the same rate each time.
Okay, they all go up the same amount each time. Go ahead, if that's your similarity, figure out what that amount is for your card. What amount are they going up by each time? And tell it to your neighbor. Okay, in your hand, you all have what's called an arithmetic sequence. Okay, what was similar about all of your sequences? They went up by the same number each time, right? That is the definition of an arithmetic sequence. Okay, it's a progression of numbers for which successive terms have a common difference. Okay. Successive terms have a common difference. Okay, that's another way of saying your sequence goes up by a number each time. And it's pronounced arithmetic sequence. Now, yesterday when we talked about sequences and series, are you okay? Yeah. Okay. Yeah. Did I spell it wrong? No. Oh.
I made it put in my head, and I thought it was funny.
Okay. Just wanted to make sure I didn't do anything to make you laugh. Okay. It's okay. It's okay. Don't pressure. Yesterday we talked about sequences and series, but everything was very disconnected. Okay. Today we're going to focus on a type of sequence, the arithmetic sequence. And so I'm going to show you some shortcuts for writing these formulas. Okay? Anytime we have an arithmetic sequence, we're going to have this common difference, right? Do we have, well, let's think back to functions. Do we have anything in our life that has a constant difference from one number to the next?
Like a line.
Oh, like a line. What is that constant that we talk about with a line? That constant change. Slope. Okay. It's just a constant change. I was looking for that word and it didn't come to me just now. Okay. So when we write the explicit definition of our sequence, it's going to look a lot like a linear equation because that constant difference is acting like our constant change, which we call slope. That D right there, that's our common difference. So that number that you just told your neighbor, my sequence goes up by 5, that is your common difference, positive 5. Now, I'm not really going to give you a straightforward way of finding C. There's going to be a few different ways to find it, okay? And we'll just talk about that as we do some examples, okay? So, I want you to go ahead and write down this sequence. we should first ask ourselves, is this an arithmetic sequence? Thumbs up or thumbs down. Is this an arithmetic sequence? Okay. If it's an arithmetic sequence, then it has a common difference. What is that common difference? Ryan? 2?
Well, maybe.
Okay, I would write it as -2 because from term to term we decrease by 2 every time. So we're diminishing by 2. Okay, so if we are going to write the explicit definition, remember this is also called the nth term. That common difference is acting like our slope. So we need -2 times n plus something. The way that I would do this is I would just think to myself, okay, if my first term is 50, what does this number need to be right here so that when I plug in 1, I get 50? If that's the case, then what would that C value be?
52.
52. When we plug in 1, -2 times 1 plus 52 is 50. That gets us the correct first term. You could also think of this as like your 0 term. Okay? So if you just want to go backwards in your sequence once, that would be this number right here. Okay. All right, now that we have our explicit definition, I want to know the 10th term in the sequence. Gabby, how do we find the 10th term? We could count until we get to the 10th term. Is there a quicker way? Probably. Jen, you seem very excited. Okay. Since we wrote this explicitly, we can just plug in 10 for n to get our 10th term. That'll save us some work, right, Gabby? Okay. That is a -2. Thank you. So our 10th term is, everyone? 32. Okay, so this is what I would like you to do. I would like you to take the card that I gave you, and I want you to determine those same 3 things. What's the common difference? Write down the nth term, so write down your formula, and then find the 10th term. You can do it in your notes, you can do it on your card, I don't care. Do it somewhere. Okay, this is what I'd like you to do. I'm gonna make you get up out of your seat for just a moment, but then you'll get to come right back. Okay, if you have a blue card, I want you to take your work to the corner by the door. If you have a green card, I want you to come up by my desk. Yellow cards, the couch. Pink cards, starting corner. Okay, I want you to all come up with a common answer for those 3 items. Okay, compare work, come up with a common answer for your problem.
Whatever it's called, 3n plus 3, and then 14.
You guys all agree? Okay, then under that green, have somebody write those 3 things. You all agree? Please send one person to write those 3 answers. You guys do? You guys all agree? Okay, send someone to write those 3 answers under blue. We all agree? Okay, send someone up there to under the orange. I don't have a yellow marker. Write those 3 answers. Okay, if you're not writing on the board, please go back to your seat. I'm sorry. I don't want you to fall asleep. I may need you to talk to Jackson. What is that? Blue group, is this the 10th term or the 15th term? It's the 15th term. You just wrote it as 10th? Okay. I just wanted to make sure that we were all on the same page. Okay. Beautiful. All right. If you would like to write, I'm going to keep these on the board for the rest of the period. So at the end, if you want more examples, you can write down the other 3 that you don't have. Okay? Now, let's talk about a recursive definition. So we're going to come back to the one that we started with. Okay, so if you want to go back to that portion of your notes, we're going to talk about the recursive definition. Now, in order to write a recursive definition, you have to give the first term. I know you can see the first term in your sequence, but if we're going the other way, you have to know the first term so you can write the recursive sequence and find the term. Okay. So then I'm going to give you about 30 seconds to brainstorm with your pod how we might write the recursive definition, knowing that we have that common difference of -2. Ready, set, go. All right, pod 4, what are your thoughts? So you're saying like 2n plus 50?
Yeah.
Okay. I like where you're going with this, but the problem is this is still explicit,
Okay.
okay? And we want recursive, okay? So let's think back to what recursive is. Remember, recursive was that funny notation where we had like the a sub n equals another term, right? Okay. So let's think about what recursive looks like. What is happening from term to term? We're decreasing by 2. So as long as we have one term, to get to the next term, we subtract 2. To get to the next term, we subtract 2. Do you agree? Okay. So to get a term, we need to take the term previous and subtract 2. To get a term, we take the term previous and subtract 2. To get the second term, we take the first term minus 2. To get the third term, we need the second term minus 2. It is also acceptable to write a sub n plus 1 equals a sub n minus 2. That means the same thing. If this is the second term, this is still the first term minus 2. Okay, I don't care how you write it. What I'd like you to do is take your card and write the recursive definition for that sequence. Okay. And when you have it written down, go to your corner.
I don't know. I'll be first.
A n equals a n minus 1 plus 3.
I don't know what I was doing now. I put n plus 1. So I don't know why. I just put it because we're going now.
You don't know why what?
I don't. How do you know whether you put n plus 1 or n minus 1?
Well, if this is n, this one has to be the n minus 1. If you write this as n plus 1, this has to be the n.
It just has
Because this has to mean term before. So like what's before n? N minus 1's before n.
Okay.
What's before n plus 1? N.
Okay. So n minus 1.
Okay, did everybody define the first term and then write the rule? Shake your head, yes, Mrs. Holman, I did. Okay, good, back to your seat. When we come back from lunch, we're going to talk about this problem. Okay, we know the 8th term and we know the 12th term, and we want to be able to write the first 5 terms. So I'm going to leave this up on the board. As you file in from lunch, I want you to start brainstorming how we might be able to do that. Okay, go to lunch. Okay, so you were to be brainstorming about this. We know that the 8th term is 25 and the 12th term is 41. How will we find the first 5 terms? Okay. If this is an arithmetic sequence, what do we for sure need to figure out? The common difference. Okay. How might we be able to figure out the common difference? Any thoughts? Darby?
Take the difference between two like numbers and then divide by the difference between the number of terms.
Okay, I like where you're going with that. So the difference of the two numbers divided by the difference of how many terms. Okay, that is essentially what we're going to do. I'm going to write it just a little bit different to have more of like a visual of what's happening. If we have the 8th term how many times will we add the common difference to get to the 12th term? We will add it 4 times, right? So we're going to take 25 and add the common difference 4 times until we get to 41. So like Darby said, we're going to take the difference between the terms. 41 minus 25 would be 16. And then we'll take that divided by the difference in how many terms there are. So divided by 4. So our common difference is 4. Okay. Now, if we want the first 5 terms, it may be to our benefit to actually write the rule for this sequence. Okay. So we know that a sub n needs to be 4n plus some number. Now we don't have the first term. How might we be able to figure out c?
We can plug in one of the terms we do have.
Okay, we do know that the 8th term is 25. So if we plug in 8, to our sequence, we should get 25. What's our C value? So our arithmetic sequence is 4n minus 7. Let's just double check. If we plug in 12, what do we get? We have 41, right? And that's what we need to get, right? Okay. So now if we want the first 5 terms, we can plug in 1 to get negative 3, plug in 2 to get 1, plug in 3, get 5, 9, 13. That will be an important type of problem. It's not as straightforward as the rest, but you will see that in your homework and probably again on Friday. Okay. Ready for a cool trick?
Yeah.
Oh, dang it. All right. I want to add up this sequence. But it's not worth our time to add one number to the next, to the next, to the next, to the next, to the next. Okay? There is a way to add these terms more efficiently. Every year excited, right? Is this an arithmetic sequence?
Yes.
Yes. What's the common difference? 2. Doesn't matter what the common difference is right now. If you are adding up an arithmetic sequence, this is what is going to happen. What happens when we add 2 and 16? We get 18. What happens when we add 4 and 14?
18.
What happens when we add 6 and 12? What happens when we add 8 and 10? Okay. How many pairs of 18 do we have? We have 4 pairs of 18. How many terms were in our sequence? There were 8 terms, and we made 4 pairs that all added up to be 18. Okay. Do you think we could apply this every single time we have an arithmetic sequence? Yes. Okay. Here's what's important. The first and the last term will add up to the same thing as the second to the second to last, as the same as the third and third to last, etc. So if we know what the first and the last term add up to be, and we know how many numbers we have in our sequence, so we know how many pairs, then we can figure out the sum very quickly, and potentially without even using your calculator. Okay. Go ahead and write this down. Write it down and then we'll talk through how that relates to what we just illustrated above. A sub 1 is the notation for what? The first term. Okay? Since we're adding up n terms, A sub n would be considered which term? The nth term, and in this case it's going to be our last term. Okay? Now, n, that is how many numbers are in our sequence. And so when we divide n by 2, that's telling you how many pairs there are. Okay? So n over 2 is giving you the number of pairs. A sub 1 plus A sub n is giving you what the first and last add up to be. Okay, so we're using this trick to add up all of these numbers very quickly. Okay, if I gave you 100 numbers, but they formed an arithmetic sequence, we would be able to add them together in less than 30 seconds. Okay? If we wanted to, really fast. Okay? So, let's come back up to here. Well, no, just kidding. We're going to do this right here. Do a very straightforward example. And then we'll tweak it a little bit to get excited. Okay. Is the sequence inside of our summation arithmetic? Yes. We can notice that it looks very much like a linear equation, therefore it is an arithmetic sequence. Okay. How many terms are we adding together? We're adding 10. We're going from 1 to 10. So there are 10 terms. So we're creating 5 pairs. Where, Sydney, what would our first term be? What would our first term be? What do we have to do with this one? And so if we do that, what do we get?
3.
Okay. Our first term is 3. Kelsey, what's our last term? 21. Can you tell us how you got that? Okay, plug 10 into 2 and plus 1. So we have first term plus last term. How many terms there are divided by 2? So we have 24 times 5, which is what? Okay. Start this out again. Except this time, I'm going to give you your sequence a little bit differently. So go ahead and write this down. Do we know the first term? Do we know the last term? Yes. Do we know how many terms there are? We do not. Okay? So we at least know the first and the last term, but in order to be able to add these up, we need to know how many numbers we're actually adding together. Now, yes, we could say, all right, we're going down by 3, so we can say 34, 31, and we can do that, but that's not always very efficient. Let's think about what the rule would be. What is our common difference, Finn? Okay, so we have negative 3n plus c, and if we want our first term to be 40, what would c need to be, Sarah? Well, we want our first term to be 40. So if we plug in 1, what would c need to be to get 40? Good. Okay. How will that help us figure out how many terms we have? Darby?
You can plug in 22 and solve for n.
Okay, we know that 22 is our term. So which n value gives us 22? So 22 minus 43 would be negative 21. So 3 is, n is. Okay, so that is telling us how many terms we have. So now we can add up the sum of our 7 terms. So we have 7 terms where the first one is 40 and the last one is 22. So let's see, we have 62 divided by 2 is 31 times 7 would be
217.
Any questions about this one? Go ahead and write this down. We're looking for the 50th partial sum of the arithmetic sequence. Negative 6, negative 2, 2, 6. Okay. Now, I was pretty nice saying that it's an arithmetic sequence. I'm not always going to tell you that it's arithmetic. You're going to have to look at the sequence and determine, yes, this is arithmetic. There's a common difference. Okay? Nicole, what is the common difference for this one?
Yeah.
Do we add 4 each time? Okay. So if we want the 50th partial sum, we know that there are going to be 50 terms, and we obviously know the first term. We're going to need the last term, that 50th term. Okay? Now, you are not going to sit there and say 6, 10, 14, 18, all the way up until 50. You're not going to write 50 numbers on your piece of paper. Okay? Instead, let's write the rule. Our common difference is 4, so we have 4n plus c. What c value would we need for our first term to be negative 6? Molly, what do you think?
If you plug -6 for,
If you plug 1 in, we want negative 6. You need to add. Wait. Yeah. You want me to add 10? What is 4 times 1 minus 10? Okay, so we're good. All right. So in order to find the 50th partial sum, we're going to have 50 terms that we're pairing up. Our first term is -6, plus we need our last term. In order to get our last term, we need to know what a sub 50 is. Okay? When we plug in 50, Connor, what is our term? Can you tell me how you got that?
4 times 50 is 200 times 190.
Okay, 190?
Yeah.
Okay, I like that. See, you talked through it, figured it out. So first term plus last term times the number of pairs that we have. Probably going to need to use a calculator for this one. What do we get? Say it louder.
4,066.
Okay, your last task is to take your card and the sequence that's on your card. I would like you to find the 30th partial sum. When you have it, bring it to me so I can check it out. The 30th partial sum.